let's look at the expected present value of cash flows that's related to this probability. Consider a benefit of $1 payable at the moment of death of X, provided that Y is still alive. So if we want to write down present random variable, we can see that $1 is payable at time capital TX. So the present value is V capital TX. And there's a payment at time capital TX if and only if capital TX is smaller than TY. So this is the payment that's only payable at the time of death of X, provided that X dies before Y. Otherwise, no benefit. And now let's look at the expected present value of this benefit. There's a standard actual notation for this, which is this capital A bar. Capital A bar means that the benefit is payable at the moment of the failure of the status. XY represents the two lives involved, and the one on top of X means that payment is made at the time of death of life X, and X dies before Y. TX is the first death. So in such a case, if we just take expectation, and again we're going to use the joint distribution for Tx and Ty. The joint density function is ftx ty st, and here S represents the value for capital Tx. So that means that in this case, the discounted value is Vs, which is $1 payable at the time of death of Tx. And because S can be anything between 0 and infinity, so we can integrate all the S together. That's from 0 to infinity. If capital Tx dies at time S, now capital Tx must be the first death. So at time S, capital Ty is still alive. So we are only integrating all these capital Ty from S to infinity. And again, write the joint probability density function in terms of the conditional density function times the marginal density of the condition. And again, we can write little f for capital Tx as the survival for capital Tx times the force for capital Tx. And for the conditional density, when capital Tx and Ty are independent, we can drop the condition. So when they are independent, the conditional density is seen as the density. So it's just density function of Ty at time little t. And if we practice in the equation, it's called 3. Plug 4 into 3, we can arrive this relationship. So for the integration, it's integration of the density function from S to infinity. That's just the survival function, survival probability that capital Ty is greater than little s, and which equals the actual notation SPY. Let's call this equation 4. Then by 3 and 4, we can see that the EPV of this benefit equals integration from 0 to infinity of Vs times SC survival probability of Y times SC survival probability of X times the force. So this formula is derived from the above derivation. And there's also some intuitive interpretation for this formula. So if we just consider any time S, the expected present value of cash flow at time S is if there's payment, the probability is that the first death occurs at time S. That's probability that X occurs at time S and Y dies after time S. So Y dies after time S, that's SC survival probability for Y. Then X dies at time S, that's the density of X at time S. So that's survival probability times force, which is the density. So the two p terms plus the mu term together represents the likelihood that there's a payment at time S, and then this times the present value gives us the EPV of the cash flow at time S. And because we are considering all the time S from 0 to infinity, so we need to add all these terms together. That gives us a formula. That's another way to verify and derive the formula. Now let's look at one example. Consider two lives, tx and ty. Assume that these two lives are independent and they are all identically distributed with the following probability density function. Now we want to determine the EPV of a benefit of 1000 at the moment of death of x, provided that y is still alive. So there's payment at time of the death of x if x dies before y. So this benefit corresponding to the actual notation that there's a payment at the moment. So we have a bar on top of capital A at the time of death of x. So x and x dies before y. So we need to put a 1 on top of x and xy. And this, if we use the intuitive way to memorize the formula, for any time s, the present value is Vs. The likelihood for a payment at time s is first y is still alive because x is the first death at time s. So it's s is survival probability y. Then the probability density that x dies at time s, that's the survival probability of x to time s, and then times the force at time s. So the last two terms, p times mu together, represents the likelihood that x dies at time s. And this together with the survival shape of y at time s means that x dies first, x dies at time s. In this case, there's 1000 payable at time s, which has a present value 1000 times Vs. Now s is just any point, so we need to integrate all the possible points. In this case, it's from 0 to infinity. And we can just use the probability density function ft to find the p, to find the mu, and therefore to determine the EPV of the cash flow.